Hey students, welcome back. Today is our third day of notes that we're taking, if you will, if we're keeping track. This is Charles' Law. We spent time last week talking about Boyle's Law, which was our relationship between pressure and volume. As pressure goes up, volume goes down. So today we're going to spend a little time talking about the relationship between volume and temperature. So, without further ado, this is page 18, Charles' Law. And today's date is 4/6. Alright? So Charles' Law, what it says is that a volume of a fixed mass of gas, so what we're saying is that we don't change the mass, at a constant pressure, we're not changing the pressure stays constant, varies directly with the Kelvin temperature. Remember back to Boyle's Law, we said Boyle's Law was it varies inversely, right? So as pressure went down, volume went up. So if we're talking about varying directly, what we're going to mean here is we're going to say that as volume goes up, temperature goes up, and vice versa. Volume going down, temperature going down. A very good thing to think about here is a hot air balloon. The reason a hot air balloon rises is because you heat up that air and it expands. So as we heat up the air is moving faster, obviously, and so it expands out. Our formula that we're going to use for this is V1 over T1 equals V2 over T2. And just a handy way to remember it or to use is this one right here, V1 T2 equals V2 T1. This is probably the best one to remember or write down or star, whatever, because this way we don't have to worry about numbers in the denominator, and sometimes I have trouble with that, so yeah. The other thing we need to remember there is that all our temperatures have to be in Kelvin, so we have to convert all of our temperatures to Kelvin. This is also another big thing right there, all right? So without kind of wasting any more time, let's jump right into a couple of examples here. And remember, the formula we're going to be using is that one right up there. V1 T2 equals V2 T1. So let's read through this question together. We have a sample of neon gas occupies a volume of 752 milliliters at 25 degrees C. What volume, we're looking for volume, will the gas occupy at 50 degrees C if the pressure remains constant? So if we go through and solve or figure out, we've got V1 right here, 752. This 25 degrees C is going to be my T1. And the second temperature, 50 degrees Celsius, is going to be T2. At this point, I would really encourage you to write this out to the side so that way we don't get it mixed up or anything like that. So I've got V1 is equal to 752 milliliters. And then, notice how T2 comes next in our formula. I'm going to write that one next, T2, and that's 50 degrees C. But we know all of our temperatures have to be in Kelvin, so we have to convert this to Kelvin. And to convert it to Kelvin, we're going to add 273.15. We did this way back in the fall, but hopefully we remember doing it a little bit. So we got 273.15 plus our 50. That's going to give us 323.15 Kelvin. We'll worry about sig figs at the very end. All right, keep rolling. V2 is what we're looking for. That's our question mark. And then T1 is 25 degrees Celsius. So we're going to put 25 degrees Celsius right there. And again, we have to take that to Kelvin. So we're going to add 273.15. which gives us 298.15. Give you a chance to kind of catch up right there. Okay, so at this point, we're ready to plug it in and solve. So I'm just going to plug in the numbers I have, 752 times 323.15. And then we're looking for V2, and we're going to times it by 298.15. So at this point, we're trying to solve for V2, so we're going to divide each side by 298.15. We're going to divide each side by 298.15. And so V2 we're trying to figure this out, is 752 times 323.15, and then we're going to divide by 298.15. And we're going to plug that in our calculator and see what we get. 752 times 323.15 divided by 298.15. And our answer, 815.0555. All right. If we look at sig figs, we're going to keep the number of sig figs of what we are solving. So we're solving for a volume, right? So we're going to save 3 sig figs in our answer. So V2 is 815, and our label, same one we had on volume before, is ml. Everybody cool with that? Questions there? All right, cool. I heard no questions. Okay, all right. Moving on to that second question. If you want to try this on your own, you're welcome to. If not, let's see what we got. Josu was done, so she got up and moved around. All right, so let's look here. We have a helium-filled balloon, has a volume of 2.75 liters, so that's a volume, at 20 degrees C. That's T1. Those two go together. The volume of the balloon decreases to 2.46 liters. I'm going to have to squeeze that in there, but that's V2. After it is placed outside on a cold day. What is the outside temperature in Kelvin? And then what is our temperature in degrees Celsius? All right. So we're looking, we've got V1 T2 equals V2 T1. Remember to get those switched so we don't mix those up. V1, our first volume, is 2.75 liters. T2 is what we're looking for. That's our question mark. We're looking for the outside temperature in Kelvin, and then we'll have to do one more step to get to Celsius. V2 is 2.46 liters. And then T1 is our 20 degrees Celsius. And again, we have to take that to Kelvin each time. So we're going to add 273.15. And that's going to give us 293.15 Kelvin. Kind of wait until we get caught up there. All right, so let's plug all this in. We have 2.75 times T2 is equal to 2.46 times 293.15. That's a terrible 5. All right, so we'll put 1 5 there. And now we're going to divide each side by 2.75. 2.75. So T2, if we're writing it all out, is equal to 2.46 times 293.15 divided by 2.75. We're going to plug that in our calculator. This temperature that we would get will be in Kelvin. So 2.46 times 293.15. Then we're going to divide by 2.75. Our temperature in Kelvin, 262.236. Which, with sig figs, we have 2 right there. So we're going to go with 2. So we're going to say 260 Kelvin. That's part 1 of this question. All right, 260 Kelvin. But the other question we have, let me change colors on this, is we're also supposed to take that to Celsius. So we have to take one more step, and we're going to remember that Kelvin is equal to degrees C plus 273.15. And we know that 260 equals degrees C plus 273.15. So on each side, we're going to isolate that degrees C. We're going to subtract negative 273, or subtract 273.15 from each side. And our answer, degrees C, again with 2, is going to be 11 degrees C. Negative 11 degrees C. Sorry, kids. Negative 11 degrees C. All right? Awesome. Thanks. See you next time.